Hello, everyone. Welcome to our mental health assistant. Our team came up with this as our final project to test out our skills as production engineer fellows from MLH and make something impactful, helpful, and relevant to users during this time. My name is V, and I am from Vietnam. I major in computer science at the University of Richmond. In our team, we have two more members, Angelyn and Tracy.
Hey, I'm Angelyn. I'm majoring in computer science at George Mason University, which is in Fairfax, Virginia, and I'm from Washington, D.C.
And finally, hi, I'm Tracy. I'm from Ontario, Canada, and I major in computer science at the University of Waterloo. So first, let's talk about what features our project has. So our project has a backend API coded in Flask, as well as a front end coded in React. So the front end and the backend have been containerized separately as well. Additionally, we also have a PostgreSQL database for our project, which has also been containerized. So in total, we have 5 total containers: the React frontend, Flask, Nginx, Postgres, and Cadvisor. We also use GitHub Actions for auto-deploying to AWS, containerizing and linting when we make pull requests and pushes to the main branch. We use a Cadvisor container to monitor the state of our website. For AWS, we use the CentOS Stream 8 virtual machine with T2 medium memory using the following inbound and outbound rules. The ports are all open because we use firewall-d to control the traffic. Finally, we are deployed to AWS on mentalhealthme.tech using Nginx reverse proxy. So this is our homepage when the user is not logged in. So as you can see, when you scroll down, we have some information on mental health and about our website and the technologies that were used to create it. So let us test the login functionality. So as you can see, we can log in or create a new user as we're doing right now. So we've created a new user, and now let us log in using that. So the login is successful as we retrieve the information from DB. And also it's stored in local storage to ensure that if you refresh the page, the user is still logged in.
So our choice of database is SQL Alchemy with PostgreSQL. So SQL Alchemy is an object-oriented database that it is easier to deal with user objects on the way of creating the backend. And the advanced PostgreSQL makes it easier to contain the database. Users can keep track of their daily journals and be able to make as many posts as they want to express their thoughts and feelings. We know that reflection is a very important part of having a healthy mental health. Therefore, we decided that the journal feature will be the main feature for our website. So as you can see, you can add the title and you can add the content of the post. You can express whatever you feel. I ate a hamburger and it was yummy, and you can save it. Yeah, so the post is saved successfully, and you can view your post, your past posts, by the drop down menu bar. And yeah, you can review what you felt and like how you feel and track the progress of your feelings and emotions. So when you log out and when you log in again, the post is still there. And yeah.
As you can see, the only way to access the journal is through logging in. But other than that, for other users outside the journal, this mental health assistant can help you find help in regards to different kinds of disorders and mental health issues. If you want to know more about how to understand mental health or how to help others, we have a help page up here, and we listed a bunch of resources and websites, playlists, funny subreddits with pictures, anything to help someone or yourself smile and make a difference in your life, maybe. There's lots of free resources online if you need therapy, and there's lots of communities online that we shared here that really helped us out. Now that we've looked at all of our components of our project, we're now going to go look into the production engineering aspect of our project. And we can see here that we are logged in into our CentOS machine, which is our instance from AWS. And I'm just going to show how we build our Docker containers using inside our AWS instance. So here I'm going to SSH into it using our key. and we have logged in. I'm going to cd into our project. As you can see, our containers are still running since we have built it in detached mode. Now I'm going to do Docker Compose down really quick and show how it's built up again. So here we're gracefully stopping all of our containers. So now I'm going to build it up again. You can see that they're being created again. So now we can see that they're just created a few seconds ago. They're all up and running, and we can go and look at our Docker Compose logs and see how our containers are doing. Backend is working fine. Flask is in its development server, and GNX working. It's following the scripts, is issuing our website mentalhealthme.tech with an RSA certificate so that when it goes to port 80, it can use HTTPS. You can see that our database is ready to accept connections. React is working. It's listening to nginx through the nginx configurations.
So you can see on the left-hand side of the screen that we have 3 GitHub actions currently running. They all run when a pull request or a push is triggered on the main branch. So the first one we can talk about is our deploy workflow. So this action deploys to our AWS instance by first SSHing into the instance and then pulling the changes from the main branch. Then using the production Docker Compose file, we remove the images via Docker Compose down and then we Docker Compose up to start the containers again. This way we can save memory. Moving on to our second GitHub action is our Docker build workflow. We build the containers necessary for production. And the last one we want to talk about is our linting workflow. So this workflow lints Python code using FLAC and Flake 8 linters and also supports auto-fixing. So the linter is actually auto-fix the code, as you can see there.
And now I will be discussing our monitoring tool, Advisor. So we chose Advisor because we learned in our curriculum how important it is to monitor our website and our services to keep a healthy and sustained web service. So as you can see, we have some sub-containers out here, and when using Advisor, you can view the CPU usage, the memory usage, and you can also see the processes, the IDs, the current ID, and everything like that to help you monitor and see and monitor the traffic.
Okay, so let's simulate some load testing on our site.
All right, so we can see in the NGINX part, the CPU is going up and by a lot. And yeah, it's because of the 500 users that putting the stress onto the service. And at the React part, we can also see that there is a spike. No, we also see some spike in the database part. So why is that the case? It's because in our implementation, we check for the login users every single time anyone entering the front page.
Okay, so that was our final project. My biggest blocker for me was working with the deployment. I was sort of confused how the service worked when it was containerized. And so it was hard for me to get the website deployed because I didn't know what was going on with nginx until I got some help from my team and my pod as well. And I'm glad that I was able to learn more about the back end of how a website works, basically.
The challenges that I ran into was managing to containerize the front and back end folders in such a way that it would be able to run in the containers and also communicate between them. So some of the next steps that I would have done if we had enough time would be to implement more monitoring using the Prometheus and Grafana to have a more interactive dashboard for monitoring.
Some challenges that I ran into was to learn about the database using SQL Alchemy because the syntax is very different from just normal SQL, and it's also an object-oriented language, so that I needed to spend more time doing research. But that's also my favorite part of the project, because learning on the way and implementing that, using what I learned to apply to the project. Yeah, so that's it. That's the end of our presentation. Thank you so much for watching. It's a very fun time for all of us to try to implement this project. And happy hacking. Bye bye.
Happy hacking!
Happy hacking.